This is a short video to demonstrate the calibration of the EM502 Energy Monitor. This is the Energy Monitor unit with the Wi-Fi module attached. We're going to be using the Fluke 43B for the calibration on both AC and DC. You must use a high quality instrument for the calibration, which is in itself being calibrated to a high standard. The load that we're going to be using is going to be a resistive load. In our case, it is some lights which we can turn off and on depending on the requirement, and the power source for both the instrument and the calibration unit must be from the same AC source to prevent earthing issues and floating voltages. Here we have the AC sensors. We've got 3 sensors on the same piece of wire. If you notice, one of these sensors is not actually clipped closed. All the sensors must be closed. So we've got sensor number 1, sensor number 2 and sensor number 3. And this is the AC sensor for the Fluke. Here is a zoomed in picture of the ExSolar EM502 and the initial screen which comes up. For the calibration, the first part of the calibration, if you push mode, you go to the time and date screen. On board there's a real-time clock, and it's important that this is within a few seconds of the actual time, because when the data is sent through via the Wi-Fi module to our server, if you want to see live data and the reaction as you turn an air conditioner on or something like that, you want the time as close to real time as possible. We use the cell phone datum time, so if you calibrate the date and time to your cell phone, as long as your cell phone is connected for the time updates, then it should be accurate enough. Along the bottom there is a little arrow which you can move left and right, and then to change a particular setting you use the up down arrows. Just note the date is in reverse, day, month, year, and it's important. Quite often people will get the year incorrect, they'll put 04. It's a little bit fiddly to do the seconds, but with a little practice you can get it right. Once you've completed that, push the mode button and you come to the next screen, which is the main calibration screen. With this you've got the voltage calibration, the current calibration for the first sensor, the phase calibration for the power factor, the current calibration for the second sensor, and the current calibration for the third sensor. And this bottom figure is indicating that this particular energy monitor is going to be used in a single phase application. That is, that each one of the sensors is going to be measuring a different single phase item in the house. If you change this to 3, then you would put one of each of the sensors on each of the phases in the house. The first sensor must be on the cable which is also the supply to the energy monitor, because the voltage is measured at this point of entry into the energy monitor. If you see on the screen there is a little arrow pointing to the left, that is the particular item which you are calibrating, and you move that arrow up and down using the up down arrow keys, and you change the value using the left right keys. So in this particular case, if you wanted to change the cost per kilowatt hour, you would use the left and right keys to change that value. And then move down to the next figure. The voltage calibration, that is the voltage which is sensed at this point. And if you see here, it is sitting at 236.68 volts, and that is the relative calibration figure. So that is the figure that we would change in order to change that to match the fluke. I'll show you that in a minute. Going down, the current calibration, that's showing a current of 2.93 amps, and that's the relative offset which is required to achieve it to match the fluke. The power factor typically, because we've got a purely resistive load, it's normally set to 1, and you generally don't have to change that. And then for the other two sensors, same story. Once you have finished the calibration procedure, the data values are only stored when you push mode for the second time. So if at some stage this unit was powered off before you change from this screen to the next screen, then you have to go through the whole calibration procedure again. So after calibrating, just push mode again and all the values have been saved. This screen is basically used in the workshop for changing the vendor ID and unit ID and some other details which we use for the configuration of the energy monitor. It's not user settable. And the last screen shows there's an arrow beside Wi-Fi, which means that this particular unit has been set up for the Wi-Fi. We've also got the Ethernet and the GSM. There's two different GSM modules which we use, and then there's a ping function as well. To activate the Wi-Fi, you would, if we were changing from Wi-Fi to Ethernet, you would move the arrow down to Ethernet, push the left arrow key, and then it would activate that, and that arrow would move down to that location. I'm not going to do it in this particular case. And all the data that's required when you push the left button, all the data is read off the SD card, which is this card here. All the parameters for the Wi-Fi for setting up this unit. And there's an RS-232 interface between the energy monitor and the Wi-Fi unit, which actually initiates this Wi-Fi unit. There's the power supply for the Wi-Fi. Now we'll actually go into the calibration procedure of the energy monitor. And if you see here, we've got the sensors. The sensor that we're going to be using is sensor number 1 initially, which is this one here. We've checked it's fully closed, and it's on our load line. And we've also got the voltage sensors for the fluke, which are stuck into the plug socket of the mains power supply. And on the energy monitor, that voltage is read at this position. Okay, going into calibration mode, the first thing you have to do is go to the calibration screen. Here's the calibration screen. Just a reminder, the little arrow shows you the one is alongside the value that you're going to calibrate. So first of all, we're going to calibrate the voltage, and we've got the fluke hooked up to the AC mains, and it's showing 238.6, and you see this is showing 238.48. It's roughly the same. We're very close. We're definitely within 1%, so that's okay. If we weren't, you would use the left right arrows to change this offset value so that that value would match your desk voltage measurement value. Okay, when you've done that, you go down to the next one, which is current sensor number 1, which is the top current sensor. we've got an offset value there of 0.504, and it's showing 2.23 amps, and here it's saying 2.27. So we need to go up slightly. Now the left arrow will take that value up, which pushes that up, and you'll find some happy point where it will actually tiny bit more. Okay, we're within, there we go, we're within 0.01 of an amp, which is not bad at all. Now the other two current sensors, the power factor, you generally don't have to do any calibration. The other two current sensors, which is number 2 and number 3, they're all on the same AC wire, so you can actually just change those values to match the top one. There's very minimal tolerance in the actual current clamps, so it doesn't matter if you interchange these, they will actually record the same value. So I just want to push this value up. Sorry, wrong location. That's the power factor. Okay, let's go down to, the arrow is alongside current sensor number 2, and I want to push that up 2.22 up to 2.26. This is showing 2.27. So I'm going to push it up, do it very slowly. There, I've got it 2.26, that one's 2.27, this is showing 2.28. I can go up a tiny bit more. Have to remember that this is only an energy monitor, it's not used for accurate bench testing of current and voltages, so within a few percent is perfectly acceptable. There we go, 2.27, 2.27, and the bottom one, I'll just push that one up a tiny bit, 2.26, 2.27. So they're all reading 2.27, which matches the current that we've got indicated on our bench test, and so that's calibrated. One thing to remember again, the values have not been written into the EEPROM until you get out of that screen. Now they've been written into EEPROM. I'll just test that and show you. What we're going to do is reset the unit. And we'll go back into that calibration screen. Go back into the calibration screen and we'll check the values. 2.27, 2.27, 2.27, this is 2.29 now. It's less than 1% out, which is totally acceptable. And that completes the calibration of the energy monitor from ExSolar.